This is PreCalculus 12, Chapter 2.4. We're going to be sketching graphs of rational functions algebraically. So that means no calculator. So we're going to do P of x over Q of x. And this is just a recap of what we've done before with some new stuff. We use the NPVs to find vertical asymptotes and holes. So holes, again, are at the common factors between the numerator and denominator. We have horizontal asymptotes when the degree of the numerator is less than or equal to the degree of the denominator. And we have the horizontal asymptote being y is equal to a over b, where a and b are the leading coefficients of the numerator and denominator, if the degrees of the numerator and denominator match. The horizontal asymptote is y is equal to 0 if the degree of the numerator is less than the degree of the denominator. And we have slant asymptotes when the degree of the numerator is 1 greater than the degree of the denominator. And we also have an additional condition that there must be a vertical asymptote. And this symbol means there exists. Or we can also think of it as there must be a remainder when we do the division. And we have to use a polynomial division if there is a slant asymptote. Here's some new stuff. We need to find the behavior near the vertical asymptotes. So generally we want to use values plus or minus 0.1 or 0.01 away from the vertical asymptotes. And the reason is there is a potential problem with zeros or vertical asymptotes if we're using plus or minus 1. So if we have two vertical asymptotes that are 1 away from each other, then all you're going to get is 0 divided by 0. So that's why we use plus or minus 0.1. Next, find the x-intercepts. This is just finding the zeros of the numerator. And find the y-intercept. So we just set x equal to 0 and solve for y. Then finally, we want to label all the intercepts and join the points smoothly. Remember, polynomials are smooth. So no jaggy edges. Okay, let's look at some examples. Sketch x squared over x minus 2, x minus 4. So we have NPVs of 2 and 4 because there's no common factors. So must be vertical asymptotes. Okay, you don't need to write these reasons down, you just write out the NPVs. The degree of the numerator is 2, and the degree of the denominator is 2. So horizontal asymptote, y equals x squared over x squared, that's 1. Okay, all I did here was expand this, or you could have just did the first term. X times x is x squared. There is no slant asymptote because the degree is equal. It has to be 1 bigger than the denominator. So, because there's 2 vertical asymptotes, we need to examine 4 points. We need to do the left and right of each vertical asymptote. 2 minus 0.1 gives us 1.9. 2 minus 0.1. And then this is 2 plus 0.1, 4 minus 0.1, 4 plus 0.1. So we just take this value, substitute into here. All we want to do is figure out whether it's positive or negative. We don't need the actual value because we know it's going to positive or negative infinity. The numerator is always going to be positive because it's squared. So we have positive, and we put a plus or a minus sign with a circle around it to denote that it's positive or negative. Doesn't mean plus or minus, it means positive or negative. 1.9 minus 2, that's a negative. 1.9 minus a 4, that's negative. So we have two negative signs. This means it's going to positive infinity. 2.1, again, the numerator is going to be positive. 2.1 minus 2, that's positive. 2.1 minus 4, that's negative. We have one negative sign, so it's going to negative infinity. Remember, if there's an even number of negative signs, it's positive. If there's an odd number of negative signs, the result is negative. Okay, 3.9, positive numerator. 3.9 minus 2 is positive. 3.9 minus 4 is negative. Again, one negative sign is going to negative infinity. 4.1, the numerator is positive. 4.1 minus 2, that's positive. 4.1 minus 4 is positive. So positive infinity. Okay, just to reiterate this, value is not important. We only need to know the sign of the result. X-intercept. So we have the numerator equal to 0. This means x equals 0. Y-intercept, we substitute 0, 0 over 0 minus 2, 0 minus 4, and that's 0. So our x and y-intercepts are the same thing. Alternatively, you can use a table of values. But you could miss key features. Okay, so those key features is this problem that I mentioned before, number 4. Okay, we're ready to plot. We have our intercept here, and we label our asymptotes. This is a horizontal asymptote, y equals 1. We have our vertical asymptotes, x equals 2, x equals 4. At 1.9, we know it's going to positive infinity. It must go to this intercept, and on the left, it's got to go to the asymptote. Okay, so no jaggies, it must be smooth. And here, we know it's going to negative infinity. And here, at 3.9, we know it's going to negative infinity. And this just needs to go up and then back down. And at 4.1, we know it's going to infinity. And then at infinity, we know it's going to this horizontal asymptote. Okay, you're supposed to do this algebraically, but you can always check your answer. So do all the work, but you can check your answer on the calculator. So we want to enter our equation. You'll have to flip back to the previous page, but it's x squared divided by x minus 2. Now be careful here. Don't put bracket because that'll imply it's multiplying this whole thing by whatever you're going to put in here. We have to put divide. So this is not divide of a divide. This divide means it's going to the denominator. X minus 4. Okay, and we graph this. Okay, there's not much detail here, so I'm going to change the window, and that's fine there. Okay, now we see a little bit more detail here. So this is difficult for you to calculate algebraically. And if you wanted to know what that point is, you'd have to use the calculator. And we're looking for a maximum, the left bound. We know this is 2, so we can just enter 2.3. And the right bound, we can just scroll. And we can see the cursor briefly there. And that's below the maximum. And we can just do the guess. So the maximum value here is at -8. And the actual point is 2.6, so that's 2 2/3, -8. It's important to note that when you have polynomials that are greater than quadratics, you don't have symmetry anymore. So you would think that this is at 3, but the maximum's not at 3. It's at 2 2/3. And I should draw that a little bit over. And it's not to scale because we don't have enough room to go down -8. But since we're doing it algebraically, you don't have to do this calculation at this point. Next example. Sketch x minus 3 times x plus 2 times x plus 4 all over x plus 4 times x minus 4. We can go ahead and start canceling. Okay, so we have an NPV of -4 and 4. -4 is going to be a whole. Because we canceled out a factor. And x equals 4 is a vertical asymptote. Because there's no common factor. We should find out what the coordinate of the whole is. So we do y of -4. And we do just the remaining factors. -4 minus 3, -4 plus 2 over -4 minus 4. So we have -7, -2 over -8. We can cancel out a -2, so we get -7 over 4. So our whole is at -4, -7 over 4. The degree of the numerator does not match the degree of the denominator, so no horizontal asymptote. Let's correct this here. The degree of the numerator is greater than the degree of the denominator, so there's no horizontal asymptote. The degree of the numerator is 1 bigger than the degree of the denominator. So there is a slant asymptote because there's a vertical asymptote, which means that there's a remainder. So we need to FOIL this. You know how to FOIL, so we'll just skip that step. We need to FOIL so we can do our division. So now we can copy down the coefficients, 1, -1, -6, and we're dividing by 4. 1, bring down the 1, multiply, 4 times 1 is 4, add the two values, we get 3. And let's just check the remainder anyways. 4 times 3 is 12. Add them together, we get 6. So slant asymptote is y equals x plus 3. Now we need to check on either side of the vertical asymptote, which is 4. So we do 4 minus 0.1, 4 plus 0.1. And we're doing the remaining factors. So 3.9 minus 3 is positive. 3.9 plus 2 is positive. 3.9 minus 4 is negative. There's one negative sign, so it's going to negative infinity. 4.1 minus 3 is positive. 4.1 plus 2 is positive. 4.1 minus 4 is positive. There's no negative sign, so this is going to positive infinity. X-intercepts. We look for the zeros in the numerator. So we have this. So x equals 3 and negative 2. We substitute x equals 0 to figure out the y-intercept. So we only plug it into the remaining terms. Y equals 0 minus 3, 0 plus 2, and scroll back up here, 0 minus 4. So we have negative 3 times 2 over negative 4. Cancel out the negative sign, cancel out a 2, so we have 3 over 2. Now we can go ahead and plot. Let's label our asymptotes. Y equals x plus 3, that's our slant asymptote, and our vertical asymptote is x equals 4. And we plot our intercepts. Negative 2, should label them, negative 2, 0. And we have 0, 3 over 2. And we have 3, 0. Let's start here. At 3.9, we have negative infinity. So we go up to the intercept. And we go from intercept to intercept, intercept to intercept. And we also have a hole at negative 4 and negative 7 over 4. So that's negative 1 3/4. So it should be close to that. And we're going towards a slant asymptote. And the right part is a little bit easier. We know it's going to positive infinity. And we know it goes to the slant asymptote, and we just connect smoothly. Again, you need to do this algebraically, but let's check on the calculator to verify this. Okay, I've already entered it in for you. X minus 3, x plus 2, and since there's only one term on the bottom, divided by x minus 4. I've also entered in the slant asymptote. You want to enter the slant asymptote to verify that it is correct. And graph. And you can see that this curve goes towards the slant asymptote. This curve goes towards the slant asymptote. So the slant asymptote has been calculated correctly. And just to let you know, I had to increase the range in order to see this part of the curve. And that completes this chapter.